All right. Well, welcome. Well, Happy New Year, everybody, and welcome to winter quarter. And I don't know. Welcome back to school. New year, new me, new you. I don't know. Okay. Well, anyway, it's good to see you guys all here. It's like it looks almost like a test day. I want to take a picture of you guys here because I don't know if we'll ever have the classroom this full. So, all right, say hi. Yeah, I like that. UCLA in the back there. All right, wait, hang on. All right. Let's get this right here. Oh, come on. Okay, all right. All right. Smile, everybody. Okay, anyway, let's see. Okay, so anyway, Stats 102A, Intro to Computational Statistics with R. This should be your first class in the 102 series. Some of you snuck into my 102C class last quarter, so this is the second time I'm seeing you. But anyway, for the rest of you, this is the first class in the 102 series, which is all about computational statistics, which is very important these days. And I'll give a few words on the stuff. But let's talk. I don't know. I guess syllabus type stuff first, and then we'll get started on course content. Okay. All right. So my name is Miles Chen. That's my email address. The course website's that. You guys already know all of this, right? And then my office is MS 8105. I think you guys know where. Yes, question? Is it possible to zoom in the kind of find let's see. I'm trying to. It's like the best I can do. All right. You'll have to bring binoculars next time, okay? Or get here early, sit in the front. Yeah, I'm sorry. Yes, question. Is what? It's not on CCLE. It's and it's not a PowerPoint. It's a R Markdown presentation, okay? So yeah, I'll post this, okay? I'll post it online. You guys can follow. But a lot of times I make changes in class, and so I won't post them until after class, okay? So you'll just have to look at this, and then when you want to review, you can review, okay? All right, oh, yeah, so my office hours will be Mondays, Tuesdays, and Thursdays from 2 to 3 p.m., okay? Or 2 to 2:50. Also by appointment if those time slots don't work for you. I'm going to put this in here. So I like when students come to office hours, okay? I like when you got questions, if something didn't make sense, okay? I'm happy to answer questions, happy to explain things. If you've got some kind of personal issue going on and you need to explain that to me, I'm happy to listen, and I'm happy to, grant extensions or arrange makeup exams or whatever. If you have questions about like what classes you should take, or like what grad school is like, or looking for jobs and stuff, I'm happy to talk about those things, okay? Those are like, I like interacting with students. I love my job, by the way. I love teaching, I love explaining, and then I like interacting with students, okay? My least favorite type of office hour is when like students come to me and they're like arguing about, they lost 8 points on the homework problem and they feel like they should have only lost 3 points or something. That, like, to me, that's annoying, okay? Because throughout the course, I'm going to say, and students get upset with me because I have different views on life, but I'm going to tell you that your grades are much less important than other aspects of life, okay? Like, you're a student right now, and so like a lot of your energy during your waking hours are put towards school and grades, and like it's put towards school, which should be meaning it's like being put towards your learning and your education. But because the way our school system's set up, like you just get evaluated with this letter with a plus or minus or whatever at the end of the course. And so it feels like everything is being geared towards that thing. And so the grades feel very, very, very important. And I get that. I was a student too, okay? But then when you're removed from the school environment, you realize there was a lot of lost time over the grades. And so, I don't know how to communicate that to you while you guys are a student, because you guys are in the middle of all of this. But anyway, I don't want you guys to get stressed out about grades, okay? Your mental health is much more important. Your personal relationships are much more important. Of course, we want you to graduate. We want you to succeed and all of that. Anyway. Come to office. If we've made a mistake on grading something, I'm happy to correct that, okay? I'm happy to correct that. And you can come visit me or the TA about that. Please don't come asking about whether you should have lost 5 or 10 points on something. Okay. All right, my commitment to you. You are the paying customer, in case you needed to be reminded of that. And so it's my goal that you are completely satisfied with the course, the teaching I provide to you. I hope you guys give me high reviews at the end of the quarter when it comes to evaluation time, all right? My job for you guys is to teach, okay? Educate you in stuff, and in this class it's computational statistics. And I've already said this, I love statistics and I love teaching, and I hope you enjoy that, okay? Expectations, all right? If you got issues with the class, come talk to me, okay? Let me know. I'm happy to hear you out, okay? I expect you guys to put good faith efforts on the homework assignments, okay? So all of these homework assignments I've written to challenge you and to, see if you're, make sure you're capable of doing these things. Let's see. I guess we'll... if I go to this course syllabus, how do I do this? Somehow it zoomed out. Okay, I guess I have to log in. Is it gonna auto log me in? Oh, life is hard. Okay. Oh, bring your phone to class so you can log in. The two, multi-factor authentication. By the way, I'm a huge fan of multi-factor authentication. You guys, not identity theft, but electric. All right, so here's the. How do I do this? Okay, I should have just opened the thing on my own computer. Okay. All right. Well, anyway. So as far as the grading goes, this is not, there we go. No, that's not the button I wanted. Okay. All right, so here's the grading. Okay, we've got 6 homework assignments, and it's 42%, okay? So when you look at a syllabus, it reflects what the professor thinks is important, okay? So here, homework is the weighted the heaviest, and that's because I think it's the most important, and I think that's where most of your learning is done. And here's the issue with homework, is that because you guys do it at home, I can't check to make sure that you are doing it yourself, okay? And I know sometimes students in the past, not you guys, but students in the past have copied other people's homework solutions. And, if you do that, you're not going to learn, okay? Learning happens. Learning happens when you struggle through something, right? You don't learn. Like, if you wanted to play basketball, okay, if you wanted to get good at a sport, you don't get better by watching people play basketball and you go, oh, that was a good play, all right? All right, that you're not going to get better, all right? You have to go out there and you have to play yourself, okay? And you have to, and if you want to get better, don't play with people who are worse than you, so you're always winning, okay? You have to play with people who are better than you, and you will lose, and it doesn't feel good to lose, but that's the only way you're gonna get better, okay? If you keep the challenges easy and low, you're not gonna improve, okay? And so these homeworks are meant to be a little bit of a challenge for you guys to get you to work hard and get better, okay? If I just gave you easy homework assignments that was easy for everybody, nobody would get any better, okay? So please work hard on the homework assignments, and if it doesn't feel good to do bad, but it's much better to do bad than to have someone else do the homework for you and you gain nothing out of it, okay? All right, anyway, and then we got all of this other stuff, right? Midterm and final, and those are just exams. I guess I'll talk about attendance and Piazza and the free points. All right, so I'll take attendance. It says on arbitrary days, but I'm going to try to take attendance often, okay? It's going to be done via this thing called the online poll, okay? And I won't do it today, but starting on Wednesday, we're going to do this, and you need your phone. And the way it's going to work is you go to onlinepoll.ucla.edu, you log in, you're going to see a quick poll for the day, and all you have to do is you just click one of the answers. It's going to say like A, B, C, D, or E. It doesn't even matter which one you choose. You just need to submit an answer, and that lets me know that you are here, okay? You have to log in either on your computer or your phone, but obviously to log in, you need multi-factor authentication, so don't forget your phone. Okay, and if you forget to fill out the attendance, you're just gonna lose the point for the day, okay? All the attendance adds up to 3 percentage points total, okay? We have about like 25 lectures. I'll probably take attendance about 20 times-ish, because sometimes I forget and I'm not taking it today, which means each class is 0.15 of a percentage point, okay? It's not that big of a deal. So if you miss, if you just forget to fill out your attendance thing, it's okay, all right? You lose 0.15 of a percentage point, but I tell you, in the grand scheme of things, it's not gonna make a huge difference. Sometimes there's other things in life, and I've written all of this in the syllabus. My syllabus has gotten longer and longer every single quarter I've taught. Okay, so I don't give excused absences. There are good reasons to miss class, and you should miss class for all of those reasons, but you're not going to get a free attendance point. Okay, you got an interview, go to your interview. Okay, your friend needs help, help your friend. Be a good friend. Okay, don't say my attendance in class, Dr. Chen takes attendance, I can't lose my 0.15 percentage point. Sorry, friend, you're on your own. My percentage point is more important, okay? Be a good friend, all right? We need people to be good friends. Your family wants you to come home for whatever reason, go home, all right? You're not feeling good, you need a mental health day, take a mental health day, all right? You'll lose your 0.15 percentage point or whatever it is. It's worth taking care of life, okay? So anyway, I've written all of that. 3% for attendance, just because I like seeing the class full, okay? And that. Okay, we've got, I'm gonna set up a Piazza, all right? It's just a discussion board. I think most of you guys are familiar. If you're not, you just log in and you post questions. You can post questions anonymously to each other. I still know who you are, okay? But your classmates won't know. I like it more when students reveal their name, but there's no bonus for that, okay? And then, and everyone will get 2 free percentage points for being awesome, okay? And if you feel like you are not awesome, that's okay. We'll keep it a secret. You'll still get your 2 points, okay? Let's talk, going back to the homework, okay? There's a whole bunch of you in the class, and we have 2 graders assigned, and so each homework assignment, the grader has to grade like 70 students worth of homework, okay? And even if they spend only 5 minutes per student, okay? 5 minutes times 70 is 350 minutes, and that's like 6 hours of grading straight, okay? Which is a lot, okay? And it's painful. If you've ever done grading, it's a miserable experience, okay? But they get paid, so it's okay. All right, but anyway, the thing is generally the graders will not read through your code chunks, okay? They're just going to be looking for output to see if the output is correct, okay? So if the question says make the Fibonacci sequence, and you write this code is technically correct, it will produce the Fibonacci sequence, but no output is provided, okay? So you're going to get 0 points for this because the grader doesn't have time to read through and say, well, is this code going to actually do what it was asked to do, okay? They don't have time for that luxury. They just want to see, did this thing appear or not, okay? And so you got to make sure the output is created, all right? So after you render your homework, before you submit it, read through it and make sure every single one of your answers is visible and easily identifiable, okay? Sometimes, and just a note, don't put your answer as a comment in the code because it'll get lost, right? Like generally, I'll tell you, the graders, they will generally not read through the code chunks, okay? That's where your work is done, but they're looking for output, okay? And so if you put your comment, your answer as a comment in the code chunk, it just gets lost as part of the code that's not being read, okay? Make sure your answer is an actual response in the text of the problem, and it's easily identifiable that this is the answer, okay? So anyway, make sure you do that. Oh, late policy for homework. Each hour it's late, you lose 5 points from 6 to midnight, and then I want you guys to get sleep. And so at midnight, the points stop being deducted, and they only resume at 6 p.m. the following day. Okay, so it's basically, it turns into 30 points a day for being late, but just during that first day, you lose, multiples of increments of 5 points. All right, is that okay? Any questions on, I don't know, grading stuff and all of this? Let me just see if there's anything else I need to highlight. I know my syllabus is 7 pages long. It's gotten really long. But, academic integrity, okay. Basically, do your own work. Don't cheat, okay? Don't publish your code or your solutions online either, okay? That's a no-no. So don't do that. Don't help other people cheat, okay? I hope nobody faces sexual violence, gender discrimination, or harassment, but sometimes, the world is an ugly place and things happen. And so we do have resources on campus for everyone, and please reach out to them, okay? Whether you're facing, whatever issue you are facing, okay, you are not alone. And there are people who are willing to help you carry your burden and move you along. But you have to reach out to them, okay? Same with mental health and student well-being. We have the CAPS service, which is excellent. They are understaffed and underfunded, and there's a long waiting list. But when you can get services, they're great. And so reach out to them as well. If any of you have a disability, need additional time on exams or whatever it might be, I think you are probably already aware of the CAE office, but you should reach out to them. Okay, and then I guess lastly, if you got questions, you want an informal meeting about, I don't know, career advice of which I am the least qualified to provide, but you still want to talk to somebody that feels like a grown-up, you can talk to me, okay? All right, let's get back to my non-PowerPoint R Markdown presentation, and let's see. All right, so we've got this. All right, so what's this class about? All right, so Are you all statistics majors? Who's not a statistics major? Okay, and what are you guys majoring in? Just shout it out. Economics, okay. It's like statistics. What? Math, okay. It's the harder version, okay. Okay, more, well, anyway. So statistics, I argue the reason why we study statistics is to gain a better understanding of the world. This is probably true about many subjects, okay? And what this field of statistics does is it allows us to draw meaningful information from data, okay? We have to rely on math to get information out of our data, and statistics can be applied to economics or pretty much any other field where there's data, which is every field of science. And that's what we have. Okay. Oh, something got cut off. But what does this data tell me about the world? And this should have been covered in your intro stats class. But there's often the question, could the data I have been a random fluke of just life and randomness in life? Or does it actually indicate something special in the process that produces the data? And you have that, okay? And then you've got hypothesis testing, which was covered in your intro class. And it was something along the lines of you would have data and you'd say, what does this tell me about the mean of the population that produced this random sample of data? And maybe you said, I have a null hypothesis that the population has a mean of 10. And when you looked at your sample, the sample had a mean of 11.3, okay? So what does that mean? Well, you had to say, well, according to math and the laws of probability, if the population has a mean of 10, then it's very unlikely to produce a random sample of 11.3. Therefore, the fact that I have the sample of 11.3 tells me my population does not have a mean of 10, okay? Or maybe it was the other way around and you said, well, if the population has a mean of 10, then it's very likely to produce samples of 11.3. And so the fact that I have a sample of 11.3 doesn't really tell me much about whether the population is 10 or not, okay? So these are the kinds of things that you should have learned in your intro stats class, okay? And so in your intro class, you have this model of reality that's talking about the population having a mean of 10. All of that, the probability rules that we calculated, your p-values, that was all based on the central limit theorem, the mathematical rules of probability, and so you relied on math to do that, okay? In this class, in computational statistics, basically, we can say, you know what, sometimes the math that's needed is actually very difficult. The analytic math is very difficult. I can't figure it out. I was only a stats major, not a math major, and so I can't figure out this hard math. And so we can ask the computer to give us approximate answers, okay? And this is more fully explored in Monte Carlo Methods 102C, but we'll get a small taste of it with our randomization and our bootstrap testing and stuff like that, okay? And so rather than relying on the analytic mathematical approach, like the central limit theorem, we can use computers' ability to produce randomness via simulations and resampling to do this, okay? And so this class is kind of an intro to that. Thematically, we can split it into two parts, which is going to be learning the tools of computational statistics, mainly R and its packages, okay? And then the second half will be kind of a brief introduction to some of these methods, okay? I made this woodshop class analogy. First, you learn the tools, right? That's technically not woodworking, and then you'll begin working on your craft. Okay, so we got to learn the tools. You've all taken Stats 20 already, which is the very basics of R. Okay, and then we'll do a little bit more R. Okay, so there's a lot of coding here. Okay, so as far as the tools go, this is kind of our tentative outline. A lot of the stuff you've already learned a little bit, but we're going to go a little bit deeper, I think, in this class. Okay, so we'll cover things like data structures and flow control, and then some object-oriented programming, and we'll look at some packages from the tidyverse, regular expressions, and we'll have a midterm exam in week 5. And then as far as computational statistics goes, we'll look at just a lot of numeric methods, okay? And so I want to just kind of say how this fits a little bit in the picture of data science. Let's see if we have this. Images for data science Venn diagram. All right, here we go. All right, so this is kind of a loose idea of what data science. I'm assuming a lot of you guys are interested in careers and possibly data analysis, data analytics, data science, and things like that. And so if you're a stats major, we can provide you with the red and green circles, okay? We are not able to provide you the blue circle, okay? So the stats major is ideally about giving you the red and the green circles, right? So you're gonna learn your math and stats knowledge, right? So that's your math and stats knowledge, that's your 100 series class. Your 100A, which was on probability, 100B, which is on mathematical statistics. You're gonna prove things like the central limit theorem, or at least not, if not prove, derive it. You're gonna derive your distributions. You'll have a mathematical understanding, or the goal is that you'll have a mathematical understanding of where these statistical probability distributions are coming from that we're using, okay? And that's what we have. And if you take that stats knowledge and you apply it to the field of economics, or you apply it to the field of psychology or whatever, sociology, whatever major, minor, or whatever you're doing, that can produce traditional research, okay? And so if you can go to any field and they'll have like the name of the field plus metrics, right? So you have econometrics, that is economics plus statistics knowledge producing econometric research, okay? Psychometrics is psychology and statistics producing, kind of this traditional research stuff, okay? And then, I don't know, so sociology and political science and all of that stuff, you can do that, okay? Fast growing is the need for, this says hacking skills, but basically computer science coding, okay? I wouldn't say computer science because we don't get into like the theory of computer workings, okay? So yeah, hacking skills is a little bit more appropriate, right? Because if you ever talk to a computer science major about computer science, you realize coding is not computer science. Computer science is really the theory behind how to write a language and operating system and instructions for a processor. But hacking skills is the ability to code and get your computer to do a lot of tough work very quickly, okay? And that's what the 102 series tries to do, okay? It tries to provide you with some coding, hacking skills in terms of the ability to code. So there's a lot of coding and all of that. And when you combine those two, that's what we might call machine learning. You provide a bunch of data and you can extract information from the data kind of in this computer algorithm-led version, okay? Combine that with an understanding of a field like economics or like psychology or like some product that you are selling, then that can become data science, okay? So you combine that with marketing understanding, whatever, then you can apply the machine learning to the data coming from that one field, and you can do data science, okay? But it's important that if you have these two circles and you can do machine learning, you cannot just jump into a field where you have no understanding, okay? If you don't, you can't just jump into, if you have no knowledge of basketball, and then somebody hands you a basketball data set, you can't just say, well, I'm an expert in machine learning, this is a piece of cake, okay? Because you'll have no idea what is good, right? Is it good if somebody scores 10 points in a game or 20 points in a game? Like, what's considered a good game, right? If you don't know anything about basketball, it's hard to pull things out, right? Like 1 block a game, 2 blocks a game, 0.2 blocks a game. Like, does that mean anything? What's a good field? Like, you have to know something about the subject that's producing the data. Otherwise, your hacking skills are useless, right? Okay, and then hacking skills and substantive expertise without math stats knowledge, we call that the danger zone, because you might be applying stuff and extracting information, but you can get in trouble because maybe it's not mathematically sound to do those things. Okay. All right, and I just have this slide that says coding and nothing else in it. Basically, expect to do a lot of coding in this class, okay? That's just, you got to be ready for that, okay? It's not a CS class, okay? But you can kind of think of it as like a pick class where there's all of your assignments are coding based, okay? Pretty much, all right? So expect to do a lot of code, right? I didn't have this slide a couple quarters ago, and somebody complained, we had to do so much coding in their evaluation. And I was like, oh, well, maybe I didn't set that expectation up front. So just so you know, expect to do a lot of coding. Okay. All of the assignments in our class will be done via R Markdown, okay? R Markdown integrates the R code and analysis and commentary, all of that into your document, okay? Because it used to be that when you created a report, you would like write a report in Word, and then you would copy code and diagrams from R and paste them into Word, and then you realize you need to make a change, then you've got to delete those images, change your code, copy and paste again, okay? But now everything is integrated in R Markdown, and so to do this, you just open up your RStudio, and then you go to File. Okay, well, my RStudio's, of course, not responding. And then you do something like New File, and we'll create R Markdown. And you'll do this, and it creates something, and then you can just knit it. And this is the generic. Oh, it says I got to save this. And it will, this is kind of their generic R Markdown thing that you render, and it will produce this, okay? And basically, you can just change the code, change the text, and you can knit them into HTML files. The HTML is the output. So when you knit this line that says summary cars produces the output when you type in summary cars here, okay? Sometimes if you run into trouble, okay, if you are working on your homework assignment and it's refusing to render, okay, I think this is on my troubleshooting portion here. One strategy that you can do is start off with the generic R Markdown document, okay, and then basically delete everything except maybe like the headline or something, and then and knit it, okay, and the document knits, all right. So this is if you're experiencing trouble, and then all you do is you just go kind of chunk by chunk. You'll copy and paste stuff from your not working document into the new document, okay? And so you'll say like, okay, I'm gonna copy and paste this into my R Markdown document, my new one that I just created, okay? I copy this, and I'm gonna click knit, all right? And then you knit it, and it renders, and you're like, okay, great. And you'll do this chunk by chunk, okay? You don't have to go line by line, but you'll go chunk by chunk, and you'll copy and paste it, and you knit it every single time. And then when it refuses to knit, then you know the error is somewhere in that chunk that you just copied, okay? And you can kind of go through and try to figure out the mistake that you've made, okay? Because sometimes people will experience issues with knitting it. You know, I mean, R Markdown does produce error messages down here. When you render it, it will produce a bunch of stuff, and it will tell you kind of where where the error is located. But in the beginning, while you are unfamiliar with all of this, it might be difficult to decipher what the error messages mean, okay? And so one strategy that will work is copy chunk by chunk, render after each chunk you copy, and when it refuses to work, then you know that there's a mistake in that part that you've just copied, okay? Another thing that I highly recommend is in RStudio, you should always have your global environment cleared every time you exit, okay? So under global options, okay, under general, when it says save workspace to R data on exit, I select never, okay? And the reason for that is because if you ever share documents with another person, okay, if you ever work with somebody else, they're not going to have all the same workspace as you, okay? So I always set it to never save, and then if you do need to save stuff in your environment, then you explicitly save it, okay? And then that will be saved in a thing, and if you need to send it over to a friend, then you can send both of those files over and they can load it up, okay? But if you just say like save the thing when I exit, you know, that can cause issues because especially when you render it, it always clears out the environment. And so anyway, I've asked the TAs to go over R Markdown in section tomorrow, okay? And so more issues will be covered there. Okay, we've got a few minutes left, and I'll just cover the very basics of data structures in R. Okay, I don't think I'll get through 25 slides here, but okay. So as far as our data structures go, we've got atomic vectors, and we have lists, and these are considered one-dimensional structures. Yeah, question?
Do we have a textbook?
Is there a textbook? So kind of, like I reference like I think 1, 2, 3, 4 books. Okay, I try to pick books that are free for you guys, and so because you pay UCLA tuition money, UCLA takes that tuition money and puts some of it towards our library, and our library has these digital subscriptions at different publishers, okay? And right now there's like this big feud between the UC system and this publisher, Elsevier. I don't know if you guys know about it, but anyway, they don't want to give us access to their journals, is basically what's going on. But anyway, all of these things, as long as you're connected to the UCLA network, so while you're like logged online here, you can click this thing, and I hope, okay, and it will give you access to this book. Okay, you can just click download here, and it will download the PDF of the textbook. Okay, so I think all of these books, I haven't checked the links today, but all of these they should go. Okay, if you live off campus, then you need to connect via the VPN. Okay, just search UCLA VPN if you don't have that already. Okay, and so anyway, you can click this, right? If you don't know about Safari Books Online, it's amazing. Okay, all of the O'Reilly programming textbooks that like sell for 40 or 50, 60 bucks at the bookstore, we have access to all of them as long as you're connected to the internet. Okay, and so I use a few of those. Okay, so but there's your textbook question and answer. So we're going to just use a couple chapters out of a few different books. Okay, well, anyway, I guess we're going to run out of time here. As far as the atomic vectors go, we have a few data types. hang on, you guys. I still have 4 minutes here, okay? So don't be rude. We've got, I guess, 6 data types, but 4 of them are the ones that we're going to use primarily, okay? We got logical, double, integer, and character, and these are the atomic vectors, okay? One-dimensional structures. Atomic vectors, the key aspect of them in R is that they are homogeneous, meaning that all of the values in that vector have to be of the same type, okay? So in an atomic vector, if it's a type double, then all of the values will be type double, okay? R is fairly unique in that we only have these 6 data types, okay? You go to other languages like C or Python, you've got things like the 32 int and the 16 int and the, you know, the single precision floating point and the double precision floating point. We only have 6 of these things, okay? And that's because we, for all of these, we have a unique missing value type, okay, or missing value thing, but anyway. Okay, so this is what we've got in atomic vectors. We'll just start off with the logical type. I'll have to continue this on Wednesday. But logicals, you got trues and falses, okay? Get in the habit of writing true as all caps TRUE and false as all caps false, okay? Because you can write capital T and capital F, but these are not reserved. Meaning, later on in your program, you can say store, like, I want the variable time, and I'm going to use the letter T to store this, and you're going to say time equals 0 at time 0, okay? Well, if you got T equal to 0 and you reference if something is true, then it's going to think it's 0, and that's like going to be give you the opposite effect, right? So don't do that. True, capital TRUE, will always be true. You can't store anything as true. Okay, so anyway, this is a logical type. And then we've got character type. These are for strings. You can use quotes to encase these things. And so you get hello is type character. Okay. Your numbers are default to be double floating point numbers. Okay. So if you just say, what is the number 4? It's going to default to being type double, okay? Which means it gets stored, with decimal places. Okay, 1.33, 4, these are all type double. So 1, 2, 3 is type double, okay? Whereas if you do 1:3, when you print it out on the screen, it looks the same. It looks as 1, 2, 3. But that is type integer. Integer does not contain decimal points, right? I mean, you guys know that. If you want an integer, you put an L after it. So the number 1 without the L is type double, meaning it's going to expect, it can store decimal points. And if 1L is going to be integer, no decimal points. This all happens invisibly to you guys, okay? You guys don't really see, and R is dynamically typed, meaning it will switch from integer to double if it needs to. And so it feels like, why are we bothering if R is going to handle all of the types for us automatically? Well, certain issues can happen when you are expecting one type and you provided another, okay? And so so it's very important to be aware of the types, okay? Yes, we can ask R to just handle the typing for us. Okay, well anyway, we'll stop here. We'll continue on Wednesday, and looking forward to a great quarter with you guys. See you then.